myself Hanasha. So today we are going to discuss topics named vector and its properties, parametrization and arc length. So let us start with vector and its properties. A vector is a quantity that is determined by both its magnitude and direction. So it is denoted by V bar or vector V bar. So we can denote by this notation or using an arrow, or we can write it as V1, V2, V3 and V1 I cap plus V2 J cap plus V3 K cap. So if I write A bar as 1, 2, 3, I can write this as I cap plus 2 J cap plus 3 K cap. Now how to find the length or the magnitude of vector V bar? So the notation is mod V bar, or we can call it as length of V bar or magnitude of V bar. So it is given by square root of V1 square plus V2 square plus V3 square. So if I want to find the length of A bar, so length of A bar will be square root of 1 square plus 2 square plus 3 square, right? So in this manner you can find the length or the magnitude of any vector. Now if the length or the magnitude, that is if mod V bar is 1, then V bar is called unit vector. Okay. Now let us study some properties, that is how to add two vectors. So the sum of A bar plus B bar, where A bar is A1, A2, A3 and B bar is B1, B2, B3. So this is obtained by adding the corresponding components, that is A bar plus B bar is equals to, you have to take the first component from each and add it. So A1 plus B1 comma A2 plus B2 comma A3 plus B3. Now scalar multiplication. So the product C A bar, where C is scalar quantity, or we can say constant, right? So if I multiply scalar quantity with a vector, so the product C A bar of any vector A bar is equals to A1, A2, A3, right, where C is a scalar, can be obtained by multiplying each component of A bar by C. So we can write C A bar as CA1, CA2, CA3. So if I have vector A bar as 1, 0 and 1 and vector B bar as 2, 1, 3. So what will be my A bar plus B bar? Just we have to add this, right? So 1 plus 2, so 3, 1 and 4. You have to add component wise. And if I take my C as 4 and find C A bar, so C into A bar, it will be equals to, you have to just multiply this by 4. So it will be equals to 4, 0, 4. Fine, so this is vector addition and scalar multiplication. Now there are few properties of vector addition. They are A bar plus B bar is equals to B bar plus A bar. So this is known as commutative property, right? Now A bar plus B bar plus C bar. So you have to write this in bracket. So it is equals to A bar plus in bracket B bar plus C bar. So this is known as associative law. Right, next A bar plus 0 bar is equals to 0 bar plus A bar, and that is equals to A bar. So 0 is our additive identity, right? So whenever we add with 0 bar means what? 0, 0, 0, then we will get the same answer. Same way this is the additive inverse. So A bar plus minus A bar will be what? 0 vector, right? Similarly, we have basic properties of scalar multiplication. So C times A bar plus B bar is equals to C A bar plus C B bar. Similarly, if I have scalars as C plus K A bar, it can be written as C A bar plus K A bar. C into bracket K A bar can be written as C into K times A bar. Similarly, this is multiplicative identity. 1 into A bar will be A bar. 0 into A bar will be 0 vector, and minus 1 into vector A will be what? Minus vector A bar, right? So now let us study the dot product of vectors. So the dot product A bar dot B bar of two vectors A bar is equals to A1, A2, A3 and B bar is equals to B1, B2, B3 is given by A bar dot B bar is equals to, you have to take the first component and multiply. So A1, B1, put plus in between, plus A2, B2 plus A3, B3. So this is the formula of dot product. Now there are some properties of dot product of vectors. So if there are three vectors, vector A, B and C, then A bar dot B bar is equals to B bar dot A bar. Now the next property is in bracket, if we have vector A bar plus B bar dot C bar, then how to modify this? How to write this? We have to write it as A bar dot C bar plus B bar dot C bar. Okay, so this way, these are the properties of dot product. Now there is one more formula, that is angle between two vectors. So if I want to find my angle between vector A and vector B, so the formula is cos theta is equals to A bar dot B bar upon length of A bar into length of B bar. So if I am given any two vectors A bar and B bar, I have to use this formula to find the angle between two vectors, right? And if our dot product value is 0, right, then vector A bar is orthogonal to vector B bar. That is vector A and vector B are perpendicular, right? That is the value of theta will be what? Pi by 2, right? So now we will study cross product of vectors. The product A bar cross B bar for two vectors A bar is equals to A1, A2, A3 and B bar is equals to B1, B2, B3 is given by vector A cross vector B is equals to, you have to write I cap, J cap, K cap. Now write your vector A, that is A1, A2, A3. Write your vector B bar, that is B1, B2, B3. You have to solve this determinant in order to find the cross product. Now there are few properties of cross product. So if there are three vectors A bar, B bar and C bar, then vector A bar cross B bar plus C bar will be equals to A bar cross B bar plus A bar cross C bar. Similarly, if I have these two in brackets in addition, vector A bar plus vector B bar cross C bar, then you have to do first cross product of A bar and C bar plus do cross product of B bar and C bar. Now for cross product we cannot write A bar cross B bar is equals to B bar cross A bar. We cannot write this, right? So we can say that for cross product A bar cross B bar is equals to minus B bar cross A bar. And lastly, I cap cross J cap is equals to K cap, J cap cross K cap is equals to I cap, and K cap cross I cap is equals to J cap. So these are the vector and its properties. So next let us study parametrization of curves. So the position vector r bar of t of any point on the curve can be written as r bar of t is equals to x of t I cap plus y of t j cap plus z of t k cap. So if I want to write the parametrization of circle, right? For example, so what will be it? Firstly, write the parametric equations of circle. So x is equals to a cos t and y is equals to a sin t. These are your parametric equation of circle. So the parametrization r bar of t is given by a cos t I cap plus a sin t j cap. Okay. Similarly, if I want to write the parametrization of parabola, I know the parametric equation of parabola, right? They are what? X is equals to 80 square and y is equals to 280, right? So the parametrization of parabola r bar of t will be 80 square I cap plus 280 j cap. Okay. So now next let us study arc length. How to find the arc length? So the position vector r bar of t of any point on the curve can be written as r bar of t is equals to xt I cap plus y of t j cap plus z of t k cap. So the tangent vector if whenever we want to find the tangent, we will find its derivative. So let us find the derivative of this in order to find the tangent vector. So r dash of t will be x dash t I cap, y dash t j cap, z dash t k cap. Just to do individual derivative of each component, right? Now if I want to find the length of r dash t, so I will take square root of this square plus this square plus this square, that is x dash t square plus y dash t square plus z dash t square. So now arc length of the curve is given by s is equals to integration from a to b mod r dash t dt. Now, if my curve is given in this form, that is y is equals to f of x, then the formula of arc length is s is equal to integration from a to b square root of 1 plus dy by dx whole square dx. So, if you are given our example in r bar of t form, then use this formula, and if you are given the example in the form of y is equals to f of x, you have to apply this formula. So now let us study example. So we have to find the arc length of the portion of the circular helix where your r bar of t is cos t I cap plus sin t j cap plus t k cap, right? And t is varying from 0 to pi. So whenever my position vector is given, firstly I have to find r dash of t. So it will be minus sin t I cap plus cos t j cap plus k cap. You have to do individual, right, derivatives of each component. Now I have to find mod r dash t, right? So it will be square root of minus sin t whole square plus take this cos t whole square plus 1 square. Now this is equals to sin square t plus cos square t plus 1. Now we know sin square plus cos square is 1. So our mod r dash t will be equals to square root 2. Now the formula of arc length is s is equals to integration from a to b mod r dash of t dt, right? Now just put the values of a and b, that is 0 and pi. So 0 to pi, your mod r dash t is what? Square root 2, right? So square root 2 dt. Just integrate. So answer will be square root 2. We can keep outside. Integration will be t. Limits are 0 to pi. Put the limit. So answer will be root 2 pi. So this is the answer of the arc length. Now let us study one more example. So we have to find the length of the curve y is equals to log sec x from x is equals to 0 to x is equals to pi by 3. Now our curve is given in the form y is equals to f of x, right? So the arc length formula is s is equals to integration a to b square root of 1 plus dy by dx whole square dx. Now firstly, so we will find the dy by dx where our y is log sec x. Just do the derivative of this. So it will be 1 upon sec x into sec x tan x, right? Now this sec x will get cancelled out, so our dy by dx will be equals to tan x. Now let us put this value in the formula. So integration from, now our values of a and b are 0 and pi by 3 square root of 1 plus tan square x dx. Now we know that 1 plus tan square is what? Sec square. So 0 to pi by 3 square root of sec square x dx. So finally what will remain? Integration from 0 to pi by 3 sec x dx. Now integration of sec x is what? Log mod sec x plus tan x. And your limits are 0 to pi by 3. Now let us put the values of the limits. So if I put pi by 3, right? So it will be log sec pi by 3 plus tan pi by 3. But the value of sec pi by 3 is 2. Value of tan pi by 3 is root 3. Right? If I put 0, right? What we will get? Log 1, because sec 0 is 1, tan 0 is 0. So log 1, and answer is log 1 is what? 0. So final answer of the arc length s is log mod 2 plus root 3. Okay. So So I hope you have understood throughout the session. Thank you for watching.